Hey, good morning, Honors Integrated 2. So today we are dividing complex numbers, but as it says here, we don't actually divide. It just looks like that. It looks like a fraction. You can't have an imaginary number in the denominator. So this right here is a no. That is a big giant nope. Can't have that. So what do? Watch and learn, all right? So what do? Well, to get rid of an imaginary number, we multiply by its conjugate. Everybody say, what? What's a conjugate? Here's what a conjugate is. Given a plus bi, its conjugate is a minus bi. Everybody notice, what's the only difference? Well, this was a positive imaginary number. Now it's a negative imaginary number. Please notice, A stays the same. Think about it as a foreign language. In conjugates, you pretty much just change the ending, and that's what we're doing here. This is a plus bi, that is a minus bi. Let me give you some examples. Okay, here are some examples of conjugates. What if I am given something like this? 3 plus 9i. What's the conjugate? Simply change the sign on the imaginary portion like this, 3 minus 9i, there's the conjugate. Don't overthink it, not that tough. Here's another example. What about negative 2 minus 6i? What should I change? There's only one thing I'm going to change, it's that. So instead of that, it'll be now negative 2 plus 6i. There are some variations, I suppose, but it doesn't ever really get too crazy. Like even if there's fractions, and what if there's just an I? Not a big deal. Again, what do we change? The only thing to change is this. So this becomes 1/2 minus I. Notice in each of these, the only sign that changed is on the imaginary numbers. These are the ones that changed. The real numbers clearly have not changed. Now, let me show you some examples of how to get rid of an imaginary number in the denominator, because we can't have it. We call it dividing, but it's not quite that. Here are some examples. All right, here are some examples. It'll say simplify. Clearly, I have an imaginary number in the denominator. Can't have that. So what am I going to do? I'm going to multiply by the conjugate. Hey, what's the conjugate? Did you say 47 plus 3i? Because that would be wrong. Did you say this? 2 minus I? 2 minus I, like that? That is correct. Now notice what I've done here. I've multiplied by the same thing over itself, which means this basically whole thing equals 1. So I'm really multiplying by 1. Also, please notice, doesn't this look kind of like a difference of 2 squares? Or I should say, the factors of a difference of 2 squares? That's going to be important because that's how our imaginary number disappears. So watch, let's do this. What am I going to do? Well, on the top, first of all, think about these as being in parentheses so that then I distribute. 4 times 2 is going to be 8, and then 4 times that negative I is 4i, negative 4i. What does that give me on the bottom? Well, again, I'm going to distribute. I'm going to do FOIL. 2 times 2 is 4. 2 times this negative 2, I is negative 2i. I times positive 2 is positive 2i, and then this is going to give me a negative I squared. This is what I wanted you to see right here. Take a look. This is what happens, right? When you're multiplying two binomials that are basically the same, but one's positive, one's negative. This is exactly what we wanted to have happen. That's going to cancel out, getting rid of our imaginary numbers. I know you're sitting there thinking, but wait, that's an imaginary number. But wait, just how about you wait for a second, watch. Because it's going to give me 8 minus 4i over 4 minus I squared. But we both know what that I squared actually is from yesterday. That I squared, if you remember, I squared equals negative 1. So instead of an I squared, I can replace that as a negative 1. Now, what does that do for my answer? Here's what it does. I get 8 minus 4i. And then I'm going to make those positive. 4 plus 1 is 5. Can I reduce? In this one, the answer is no, but I'll show you an example in a second that you can. What do I want you to see in this? I want you to see that I basically multiplied by 1 and that these are the same binomials, but one's plus or one's minus, so these middle terms cancel out. And don't forget that I squared equals negative 1. That's how I get rid of the imaginary number in the denominator. Any questions? No? Okay, good. How about a problem like this where there's not a binomial in the denominator but a monomial? You still can't have that. So what do you multiply by? Well, you know, the conjugate of that would be positive 3i, but the truth is, since I'm just multiplying by 1, I could make it negative 3i, but just to stay consistent, I'm just going to multiply by the conjugate, like that. And then what does that leave me? Well, of course, I have 4 minus 3i. That's going to be 12i. And then this is going to give me negative 9i squared. But as I've said several times now, you have to remember that this I squared is not I squared. It is a negative 1, which leaves us 12i over negative 9 times negative 1 is positive 9. Can I reduce this? This is going to be key, so pay attention. Yes, I can reduce this because when I reduce, I divide by 3. Now, this is not a big deal on this problem, but it's going to be a big deal on the next one, so pay attention. What do I get? 4i over 3. Can I reduce any further? I cannot. There you go. All right, this is about as tough as it gets when I have binomials on top and bottom and I've got an imaginary number that I can't have. So I'm just going to get started. I'm just going to multiply by its conjugate, which, remember, all I'm going to do is change the sign on this negative, on the imaginary one. So that'll be negative 4 plus 2i, bottom and the top. Once again, recall, I'm multiplying by 1, so I'm actually not changing anything. I'm just rearranging it, which is convenient. And of course, this is positive, that's negative. That imaginary number is going to drop out. I'm going to end up with an I squared, which is negative 1. Everything should be beautiful. Let me do the distributive property, little foil on top. This is going to get a little tight. Let's see, this is negative 40. Then when I do the outside, that's positive 20i. I do the inside, negative 12i. And then the last is plus 6i squared. Barely. All right. On the bottom, I get positive 16 when I do this one here. Do the outer, I get negative 8i. I do the inner, I get positive 8i, and then I get negative 4i squared. Once again, as expected, these two cancel out. I've got some like terms that I can combine up on the top. I'm going to do that. I'm going to show all my work, every last step of it, all right? And I'm going to move this over here. So this is going to go right here. So now I've got negative 40. I'm going to add these together. This is negative 30. No, it isn't. That is positive 8i plus 6i squared over, on the bottom, I've got that 16, and this is minus 4i squared. Now, remember, you know what I'm going to say. What is I squared? I squared, negative 1, right? So I'm going to deal with that in a second. Same up here. This is also negative 1. So I'm going to try to rewrite this one last time. Here's what I get. Negative 40 plus 8i. 6 times negative 1 is minus 6. I get this negative 4 and that negative 1. That's 16 plus 4, and here's what I end up getting. I can combine this one here and this one here, which is negative 46 plus 8i, like that. Everything over 16 plus 4 is 20. This is pretty good, but I can reduce it. I'm going to show you that in just a second. So the question is, can I reduce that? And the answer in this case is yes, but it only works if you can reduce all 3 of these numbers. In other words, if you can find the GCF of all of those and divide. The GCF, as I can tell, is 2. 2 goes into all 3 of those numbers. And so what I need to do is divide by 2. But that's the thing. I need to divide the whole numerator, everything, by 2. So if that wasn't 46 and it didn't divide by 2, I wouldn't be helping myself at all, but it is. So here's what I get to do. I get negative 46 divided by 2, which is negative 23. I have this plus 8i divided by 2. That's plus 4i. And I got 20 divided by 2, and that's 10. Now look again. Can I reduce these 3 numbers? The answer is no. I could reduce the 4 and the 10, but I can't, right? Because this 23 is messing everything up. So this is my final answer. Do not cross those out and simplify. Okay, so now really all this is pointless if you don't actually get to use it. So everything you've been doing yesterday and today have been skills, but now I can actually solve this quadratic equation using square roots, and my answer is going to be imaginary. So I'm starting to get to a point where I can actually find imaginary answers. So I get 4x squared equals negative 38, and 13 is negative 25, like this. And if I divide by 4, here's what I get. X squared equals negative 25 over 4. Now, you know, the next thing that we do is we take the square root, because this cancels that. But what does that leave me? Well, I want to remind you of something. I want to remind you that what we can do is separate this into the square root of negative 25 over the square root of 4. Now, I know the square root of negative 25, it's plus or minus 5i. The square root of 4 is 2, and there's our answer, plus or minus 5i over 2. Got to have the plus or minus. That stands for two answers. Remember, I have 5i over 2 and negative 5i over 2, which is what we would expect because of that exponent of 2. The degree is 2. I expect two answers. That's them. This is the shorthand way of writing those. Here's my last example. Make sure you listen for directions at the end, okay? So I'm going to solve this. I'm going to add 8, and I'm going to add 8 like this. And then I get negative 5x plus 11 squared. This goes away. That equals 80. Then I divide by negative 5 and divide by negative 5. This goes away. X plus 11 squared equals negative 16. Here's where I get imaginary. You know, I've got this variable term squared and isolated, so I'm going to square root it and get rid of that. It only works because it's in parentheses. Then I get x plus 11 equals, of course, this is plus or minus 4i, like so. But what do I do with that? Well, it's not that big a deal. I'm just going to subtract 11 on both sides. And what's that going to leave me? Simply this. X equals negative 11 plus or minus 4i. This is a legitimate answer. In fact, it's two legitimate answers. Remember, the plus or minus gives us those two answers. It's going to be this. X equals negative 11 plus 4i and negative 11 minus 4i. There we go. So you'll be doing this on tonight's worksheet. Remember, take a picture of your worksheet, post it to the Google Classroom, and I'll be updating grades here hopefully today. All right? Thank you.